All right, everybody. Now that we have successfully made our way through the various lectures on probability and conditional probability and chi-square tests, there's going to be a homework about them. So this is homework number 10. It's due on Friday, December 10th, which is 2 Fridays from now, today being Tuesday the 30th. So we have 10 days to work on this. This is just after the last day, the last official day of classes for the semester. There is still there's a bit of confusion because there's still going to be one more homework after that, which kind of functions a little bit like a final exam, but also kind of functions a little bit like an optional homework. But essentially, it's going to be about the material we cover in the last week of lectures, which is next week. So this is about, this particular homework is about what we've talked about the previous 2 weeks. So there are 3 problems in it. The first is about probability. So this is kind of just a fun question at the beginning. So as an age-old Simpsons fan, there was a long time ago a Simpsons episode where they played Scrabble. And at the beginning of the game, they show that Homer has the word oxidized sitting in his rack and has no idea what to do with those letters. And then Bart has the word Ouija in his rack and just tries to pretend that it is a word. And then, hilarity ensues. Anyways, the question I want to ask is, which is greater, the probability of drawing the tiles oxidized in that order, or the probability of drawing the tiles Ouija in that order at the start of a Scrabble game? So let's just pretend this is the beginning of the game. And then I've got the distribution of Scrabble tiles down here, which if you're a Scrabble player, you're probably well familiar with. And if you're not, well, yeah, you can use this to your advantage either way. But there are 100 tiles total. 2 of them are blank and can be used as like a wild card, any kind of letter. But those are separate issues. Just when I talk about oxidized or Ouija, like I mean these specific letters, right? Not the blanks. So another note, if you're not a Scrabble player, is that when tiles are selected from the bag, I've got my bag here, right, by a player at the start of a Scrabble game, the tiles are not replaced in the bag. So you select 7 tiles. The first one I got here was a T. Okay, so on and so forth. You don't put it back in the bag. You just put it in your rack. Okay, so on the basis of that, figure out what these probabilities are, and then tell me which one is greater. That's problem set 1A. Okay, so the second Scrabble-related set of questions is we're going to reduce the overall set of tiles in the bag. So instead of all of these guys, we're going to only use the 5 vowels and these 5 coronal consonants, L, N, R, S, T. Yeah, and so I've got those letter distributions there. So, and just to be clear as well, when I say letter distribution, in the bag, there are 9 A tiles. That's what that means. And there are 2 B tiles, so on and so forth. Likewise, there's 9 A tiles in this bag. There's 12 E's. There's 4 L's, so on and so forth. Okay, we're only going to play with these tiles, which all happen to have a value of 1 point in the game. See, there's a 1 by that T. In this game, a player will select one of these tiles, determine whether it is a consonant or a vowel, and then place the tile back in the bag. So this is a different game altogether. On each round, a player selects 7 tiles in this fashion, or I guess you could say each turn. So select a tile, figure out if it's consonant or vowel, put it back in the bag, mix it up, select another tile, determine whether it's consonant or vowel, put it in the back of the bag, so on and so forth. This would be probably a really boring game, but we're going to play it theoretically here. So you select 7 tiles in this fashion on each round and then determine whether each is a consonant or vowel. A player will win the game when they select a string of 7 tiles that begins with 1 or more consonants, followed by 1 or more vowels. Maybe I should make this bigger. And ends with 1 or more consonants. So that is some sequence of the form C sub n, V sub n, C sub n, where C sub n indicates a string of 1 or more consonants in a row, and V sub n indicates a string of 1 or more vowels in a row. And this is only kind of tenuously related to linguistics at this point, but you can kind of think of a structure like this as just like a really big syllable of some sort, perhaps. Okay, so with that in mind, that's the structure of the game. Question number 1, how many different winning sequences are there that contain the following number of vowels? So a winning sequence is one that takes this form right here. Some sequence of consonants followed by some sequence of vowels followed by some sequence of consonants. Okay, how many of those sequences have 0 vowels? How many have 1 vowel? How many have 2? So on and so forth. Come up with different numbers for each of these possibilities and let me know what the right answers are. Question number 2, what is the probability of a player selecting a winning sequence with each of the following number of vowels? Right, in that case, say, going back to this being a winning sequence, how many of those winning sequences, let's say you have a winning sequence with 0 vowels in it, what is the probability of selecting that winning sequence? Or if you have a winning sequence with 1 vowel in it, what is the probability of selecting that winning sequence? And again, it just has to be a vowel somewhere in between, some strings of consonants on either edge, right? So this is the number of possible different sequences with this number of vowels in them, and this is the probability of drawing a sequence with this number of vowels in them, right? Okay, so number 3, what is the combined probability of a player selecting any one of the winning sequences? So overall, what is the likelihood that when you play this game, you're going to get one of these sequences? And for that, it will help to know, it will help if you answer the questions 1 and 2 correctly in order to answer question number 3. That's all I'm going to say about that. But also be sure to explain the reasoning you use to derive your answer. Don't just spit out numbers at me or R code or whatever and expect me to sort of derive what you were thinking. Tell me explicitly how you got to the answer you got. Show your work, as they say in math class. Okay, that's question set number 1. Problem set number 2 is more sort of perception experiment related because it comes from a couple of different experiments I've run over the years. So problem set 2, question A, the following set of data comes from an experiment in which listeners learned to identify a set of 6 different talkers. In this condition of the experiment, each talker was speaking in a variety of different voice qualities, thereby making the identification task considerably more difficult than it would have been otherwise. So, and this, like I said, is an experiment I've run. And you learn at the beginning of the experiment, you have 6 different voices, and then you hear one word spoken from one of those 6 different voices, and you have to guess which person said it. And then so you do a number of trials like this with feedback, and over time you get better at linking up what the sound of the word is to the person's voice, or at least their name, right? The data here comes from the first training session of this experiment. There were 60 trials in this experiment, and the data show who the listener was, just a subject ID number. And then for each listener, it shows how many talkers they identified correctly out of 60 trials. Yeah, like I said, the talkers are speaking in a variety of different voice qualities, so it makes their voice sound potentially radically different from one trial to the next. That's why it's fairly difficult to do this. And so basically what this is saying is like listener 16 heard 60 different words, and for 27 of those words, they identified the person speaking it correctly, right? And so I think that's one of the better scores here, but there's others which are lower, like 13, so on and so forth. Just figure out, for question number 1, how many of the listeners are performing the task at a significantly better than chance level? How do you know? So again, answer the first question, and then show your work or tell me your reasoning behind that. Don't just tell me like who's doing better, right? Tell me whatever test or reasoning you happen to use to figure that out. Otherwise, that one's pretty straightforward. And part B is going to be fairly similar, except it is using a different data set. So this data set comes from a different condition of the experiment in which listeners were first trained to identify the same set of 6 talkers, but they were speaking in a particular voice quality this time. So like one person might constantly be speaking in breathy voice, and another person might be speaking in Greeky voice or something like that. So it makes the voices sound more distinct in training. But the trick for this experiment was that in the last session, each talker spoke in a different voice quality than the listeners have learned from. So the person who's always speaking breathy, all of a sudden maybe goes to Greeky voice like this, and they might sound different. And in fact, it does. So the listeners had a difficult time making that sort of transition or generalization for the speaker's voices. And this table lists the number of talkers they identified correctly in that session out of 60 trials. So overall, the number of trials is the same in both data sets, but the number of correct responses is a lot lower here. So because it's just complicated. In fact, there's even one person who got 0 right out of 60, which is amazing. Anyways, so question number 2, how many of these listeners in this data set are performing the task at a significantly better than chance level? And how do you know? Show me your reasoning, show me your work for how you do that. And question number 3 is how many of these listeners are performing the task at a significantly worse than chance level? How do you know that? All right, just explain to me not only the answer, but how you got there, right? Whatever test or reasoning you use to figure out the answer. Problem set number 3 is a different listening experiment. This actually comes from my dissertation a long time ago, in which listeners were attempting to identify the place of articulation of stops in vowel, stop, stop, vowel sequences. The vowels in these sequences were always ah, or something like it. The stops were always voiced and took one of 3 different places of articulation: bilabial, alveolar, or velar. So these sequences are basically like abga or agda or something like that, right? And so I just played these to people and said, tell me what the sounds are in the middle, the consonant sounds are in the middle, basically. So the tables below show the total number of responses given by the listeners for 2 types of consonant clusters: homoorganic clusters like ad-da or ag-ga, something like that, with 2 stops that shared a place of articulation, and also heteroorganic clusters with 2 stops that had different places of articulation. So this would be like the abga or adba, whatever. The rows in each table show, well, so first of all, these are just responses, right? So there's an overall set of how many stimuli they listened to, but these are just showing you what kind of responses they gave. So the rows in each table show the number of times the listeners responded with a particular place of articulation for the first consonant in the cluster, the C1. So this is when they think the first syllable ends in like a B or maybe a D or maybe a G. And then the columns show the number of times listeners responded with each place of articulation for the second consonant in the cluster. So these would be like ba, da, or ga. So this combo right here would be ab-ba, this would be ab-da, and this would be ab-ga, so on and so forth. But in this case, they're only listening to these homoorganic clusters, which is one of these 3. And this is the set of responses you get. The second set of data is the total number of responses to heteroorganic clusters. So the response data is structured in the same way, except here the stimuli were different. They were listening to things like abda or adga, so on and so forth. And these are the responses you get. Okay, so there's only 2 questions for this problem. So question number 1 for the homoorganic clusters. So for this data set, are the C1 responses independent of the C2 responses? Tell me what you think the answer for that is, and then also tell me how you figured out that answer. How do you know? For question number 2, it's the exact same question. So for the heteroorganic clusters, the only thing that differs here is that we're looking at a different data set. For the heteroorganic clusters, are the C1 responses independent of the C2 responses? How do you know? Yeah. Okay, that's the homework for homework number 10. It's due in a week and a half from now. Let me know if you have any questions. I'm sure that a few will arise, but otherwise, have fun.